Hello everyone, welcome to Elite Engineer. First of all, before I begin to my lecture series of optimization problem and algorithm, I would like to request you, if you're not subscribed to our channel, please subscribe, because I'm working really very hard for you guys to bring such content and make things feasible and possible free of cost. So, in this lecture series of optimization problem and algorithm, we're going to see various optimization algorithms, and that too you will learn and you can implement in any domain whichever you're working. I belong to the power field, and I will just tell you not only the power examples but also transportation and the wheresoever you can think the optimization is possible, there you can implement this technique of optimization. So let's begin with our optimization, starting with our optimization elements, right? So before I will begin with directly the coding of optimization, I would like to tell basics for this optimization, right? So when we start with our optimization, there is some objective function. Now you will think that what is our objective function? Okay, this is basics for your pillar. Like whenever building starts constructing, you should have the base clear, right? Because if you want to make first floor, second floor, third floor, the base should be strong so that the building should not collapse. That's why I'm teaching you this. Okay, now we start with the objective function. We need some objective function so that we should know what we want to exactly do. So when you when some problem comes to your mind, like you need to minimize or maximize something, so you should know what exactly you need to minimize or maximize. For that you should know my objective function, right? Then there comes some of the constants. And then in constants, we have some of the data. We should have some data. That's why we are creating the objective function, right? Now, what happened here is the constants show the relationship between the data and the objective function, right? So this is a relation. This gives a relation between these two of things. Now, what happened here is not only one. We can have multiple objective functions, and that's why we call it a multi-objective problem formulation, right? So we can have a 2 objective function, 3 objective function, and so on. So if you consider more than one objective functions, like for example, we have to minimize the cost of traveling, and we have to maximize the comfort level also. For example, we have an electric vehicle. Okay, now you want one company, some like a Tata Motors, want that how optimal battery capacity it should design so that it can minimize the cost of traveling, so that the electric vehicle battery can be charged at greater extent. Like it can be run to if it is running for 5 hours, it can run up to 10 hours, and also it can increase the comfort level. How comfort level it can increase? Like you can switch on air conditioning, you can switch on your radio, and some extra electronic items you can use you can charge your phone also in that car. Compiling everything will create my objective functions. So many objective functions, right? If we talk about the power system, like in power system, the main objective is to maximize the reliability of the power system and minimize cost. If also you can take, like first objective is my reliability of the power system. You have to improve, you have to maximize, and the second is to minimize the cost. So this objective you can create in power system. Now what happened here is sometimes the objective function is inside the constants also, right? Now to give you an example for that, for example, to do a job. Okay, so cost is less than something we can call, okay, and we can maximize the reliability also. So this problem can come under the objective function that comes under the constants, right? I'll explain you in much more detail when we go forward in our course, right? Then comes sometimes what we have is our data is uncertain, right? So that also create a problem. Our data is uncertain. See, these 3 data is uncertain, so it also create a problem. Now what to do? Now these things we're going to explore in our upcoming optimization formulations and algorithm creation. To start with, we have a basic optimization problem, that is our diet problem. Whenever someone starts with optimization, to learn the optimization, how it is working, they start with the diet problem. For example, I am a human being. Okay, I'm a very fat guy. Now I want to reduce my fat. So nutritionist recommend me to take this diet in which has high amount of vitamins and less amount of fats. and less amount of carbohydrates. But you are very poor guy. Now what happened here is the optimization problem that comes into your picture is the minimization of the cost and maximization of what you want. That maximization of proteins, vitamins, minerals, and the minimization of carbohydrates and fats in your diet. That's why I'll become slim and trim, and I'll have a body, I have a six-pack abs, right? So that is the issue here. Now, to give you a clear brief about diet problem, so here the main objective is what to eat so that we can have the optimal vitamins, like as I already told you. So we will have some of the objective functions like minimization of cost of diet, minimum calorie, the amount of fat you should take, that should be less than some value, some X amount of value, right? Then there comes how much each food should be taken in order to satisfy some of the criteria that comes under the diet problem. Okay. Next comes the clash of clan problem. This is one of my favorite problems of optimization technique. If you have ever played this clash of clan game, you will come to know that what I'm talking about. See, these are the base which they have created. So what happened here is this base, this has some of the walls. This is a gold mine. This is a gold mine, and this is a elixir collector. Okay. Now what happened here is if you want to have walls, this is a archer. Okay. It has some of the arrows, bows, and this is a elixir collector, a dark elixir collector. So this is everything. Now you need to optimize your walls, archers, wizard. This is a wizard tower here. This is a wizard tower. This one is a wizard tower. This is also wizard tower. And these are hidden. This is I forgot this name. And there's some hidden Tesla also. And this is a king, queen. So now you need to optimize the location of your walls, this archer queens, this wizard tower, so that your defense would be good. Now here the problem comes how to actually arrange in map, right? So that is my optimization problem. So see this thing, actually everyone created its own base, clan base. So this base, see, someone has put all the walls here and all the collectors and every defense here. So someone can attack from this side. So this is one of the worst base. This is not proper optimization. So this is also not proper optimization. This is a proper optimization. This is a proper optimization. This thing can be optimization, cannot be optimization based upon how he has used. See, this defense is there. This elixir collector is there. So we need to study and formulate whether it is working as our proper optimization or not. They can also be based upon some optimization, like in this, if I want to attack on someone else's base, I have to take like giant, wizards, archers. These are some of the you can call, if you have not ever played this game, so they are some of the human beings you can call. Some of human beings we need to attack to some other country. You can think like that. So which human being we should take, which equipment we should take, which weapons we should take. We should take mortar or not. We should take our missiles or not. We should take our nuclear bomb or not. So we need to optimize according to that, right? So this is according to that, like how we can attack to the other base, right? So we need to create some objective function. We have a constants, and we have to deal with the data of this data. So the team for attacking we want to create, and what type of equipments or what type of people we have to choose. That is the problem in this. Then comes our warehouse problem. Now see, this is a warehouse. What happened? Not only warehouse. What happened if we arrange the things in improper manner at our home? We get frustrated, right? So that is one of the problem when we talk about the warehouse problem. Now here the problem is how to arrange the different items, which two items you have to put together, so that if you want to use two items together, they can be taken out in the quicker manner. So here the objective function should be minimize the cost of operation of the warehouse and put in such a way that it can be easily accessible if you know that where they are when you require them, right? So this is a warehouse problem. Then comes very, very famous problem, that is our transportation problem. You know that we have some X amount of factories and we have some Y amount of warehouse. You want to send some parts, some equipment or something you're manufacturing from factory to warehouse. Now these factories have some vehicles and they have to just go to warehouse. Now how much each manufacture to transport to demand side in a way? So that is one of our optimization problem. And the amount of capacity to manufacture, because everything has some limit for production, and that thing, is also an optimization formulation. Like it has some limit. It cannot produce infinite amount of production capacity, right? And then the amount of capacity of manufacturing limited, hence we call it as a data. Data means limits for optimization. And we have to include sometimes, for example, emissions, the pollutions, and that is, we have to minimize everything. It should be there. Minimize the pollutions, emissions. That is one of the optimization problem itself. So there will be multi-objective formulation in this part. Right. The next part is our flight problem. Now you are traveling from one country to another country, and your flight is not only the single flight in the sky, right? So this is one of the complex problem, I could say. There are huge number of countries and everyone has its own flight. Now they are flying from one country to another country. So air routing planning should be there. Now which route to follow comes under optimization. For example, you're giving some X amount of fare to that flight, traveling to the flight. Now the flight fuel should be minimum. Why? How airlines charge you the some amount of fare? Because it is taking the fuel charge and the profit from that, right? So fuel charge must be minimum and the travel time should also be minimum. There it creates a minimization of optimization problem, the flight problem, if you're traveling from one country to another country. Also, one of the problem here is you can also create a maximization of comfort of the passengers. And that can also be one of the problem that we have to avoid the any accident, like it should not clash with other plane, right? In the sky, there is no instructor to say like you have to fly from there. It's not a ground, it's a sky, right? And the data is the flight data, okay? And there are some objective functions, the constants and the data in this case, right? Now coming to the power system, I belong to power domain, so I'll just explain, I think, power system optimization in much more detail. I hope this will help you to create a greater impact to the society and the renewable energy domain. So we have some bus system, right? So what happened here is we should have some generating units, renewable energy generation or thermal power plant generation, or we can call it diesel generations. So we should know the location of generating units and we should know the cost function of each generating units, right? Now the problem here will come, we need to minimize the total cost of generation, right? And the total losses in the system should be minimum. That is one of the main objective problem in optimal power flow for some X amount of system, like if you consider 33 bus system or the bus which I have already shown here. So the data here should be a line capacity, impedance and the demand. So see, every bus should have some demand. See, this is a generation and every bus should have some demand. See, this demand in this bus, there is some demand and every bus should have some demand. And constants here is our KCL, KVL of our system. We are going to explore this in much more detail and we are going to implement this in the real life scenarios. I'll just consider some renewable energy projects also in the future if the time permits, and I'll explain you how we can integrate our system for an optimal power flow. That's all for this video. I hope to see you in the next video, and there I will explain you everything in much more detail, and we'll start with the coding part also in the upcoming videos. I hope to see you in the next video. If you're not subscribed to our channel, please subscribe. I'm working really very hard for you guys. See you in the next video. Thank you.